this is really like the first of two workshops. Today we're gonna look at intro to R. Tomorrow we're gonna look at data cleaning and the process of cleaning specifically for data sets that are about social networks. So today there is not gonna be a lot of social networks stuff, but that's deliberate and that's intentional. And today I made sure to include in this introduction, there are many things that you could include in an intro to R workshop, but I made sure to include the things that I think you are really likely to be using more and more. The thing with R is that it's very finicky. It has many pros and cons, but it sometimes can be difficult to use. And so, because you're going to be needing to do some very specific things for your specific data set, for your specific project, odds are that at some point, today, tomorrow, in months, you're gonna get stuck in something. You're going to have to learn something new in R to make it work for your project. And so, because of that, it's very important that you learn the fundamentals, how things work in R, what are the main parts, and how those parts are moving. Because if you understand these principles, the basic things, then you're gonna be much more likely to get unstuck easily. Google can help you and can help you a lot, but there's only so much you can do with Google if you don't really know how to search for an answer or whether an answer that you found is really a good answer, how to interpret the answer. So this is why we want to make sure that we understand the principles first and we understand like the moving parts. Okay, so having understood like what this is about and why we're here, we can go into understanding how this will work. So there's a Dropbox folder. You can go to the Dropbox folder for today. So this would be the folder. And here we have like some files. So this, if you open this intro to R script, if you open this one, it will open in RStudio. And if you open this, you will see exactly, this is what you should see. Okay? Right? In the Dropbox folder in the tiny URL folder that we gave you, like, okay, so yeah, copy and paste. Yeah. Yeah, definitely. Yeah, it's not opening RStudio in the viewer. So if you download the R script to your computer and then try to open it from your computer, then it's going to open in RStudio. It should. Or you could right click on it and click open with and then select RStudio. That's another thing that you can do. Okay? Okay. How many people? How many people have it open? Can you raise your hand if you have it open in RStudio? Okay. Can you? Okay. So can you please raise your hand if you have it open this R script in RStudio? Okay. Okay. So the majority of you is there. Okay. Is Okay, thank you. Yeah. So that's the first file that we are going to work with. That's the file that you are going to use, that you're going to be looking at and running the code through. And in addition to that file, in the Dropbox folder, there's this file, intro to R executed guide in HTML. If you run that file, if you again like don't put it in your computer, and then bring that file into a browser. It could be any browser really, Chrome, Firefox, Safari, it works on all. Then you will get this, okay? And this is exactly the same code that you have in the R script that we were looking at. Is this exact same file, but it has already been executed. So I already ran all of the functions, everything is in there. So in that way, you can see everything that I did, like all of the results that I got, and you can see exactly like how this should work in your machine. I'm gonna be showing all of the steps that I did in this screen because it's easier for me, visually it's easier with this file to show it in the screen. But no, that is the same thing that is going to appear in your console. We're gonna talk about that just in a sec. Okay. So with that, let's get started. The first thing that we are going to do is try to talk a little bit about the environment in R. Why would we even use R if it's so problematic and so finicky? We want to use it because compared to other software, like for example SPSS, the fact that you have a series of code and that you can repeat over and over again makes your work reproducible. You don't have to remember every time what you did the last time. You have it in there and you can run it and rerun it. It's also highly customizable. So you can do many, many things in R that you couldn't do in other software. And then is where the field is going. So many, many developments in social network analysis, many new tools, the new developments, the new stuff is coming in R. So this is why it's very important to start learning this software because the newest things are going to come in this software. Okay, so let's talk a little bit about the environment. When you have RStudio open, you are going to see 4 panes. This is the source pane, and this is where you have your script. The script is this series of steps that you have. This is the script where you put all of your code, where you put all of the tasks that you are going to do. This is the environment. This one here is the environment pane. And this is where you will see where all of your objects, when you create objects, when you load a data set, when you do like, you create any object, it's gonna be open here, it's gonna appear here in their environment. I know that some people have the history tab in the environment, that's the one that they have selected. I would suggest that you change that and select the tab environment because you are going to use it much, much more than the history tab. Okay? Then you have this third pane. The third pane is the console. And this is where all of your output is going to appear. This is exactly where you will see all of the results of the things that you are running in your script in the source. And then you have a fourth pane. The fourth pane is where you have your files, the plots. This is where all your plots will appear. The packages, which tells you which packages you have loaded and you haven't loaded. We will talk about this in a minute, so you don't have to worry too much. And you have also like the help tab where you can get help, and we will explore a little bit more of this. But I just wanted to show you in general what are the 4 panes and what you can see, what you will see in each one of them in general terms. Okay? If you want, I know that some people really don't like the way that the panes are. They would prefer to have either the console at the right side or like have a different layout. And that can be sometimes very important for your workflow. So if you want to change that, you can go to Tools, Global Options, Pane Layout, and then you can change here, clicking on these tabs, clicking this drop-down lists. You can select the ones that you want to be in each of the 4 places. Okay. By the way, I'm going to mention that throughout the code, throughout this code, and also the file, the HTML file that you have, this is super well annotated. I put lots of instructions and details about things in here, so that you don't have to take many notes, and you can pay attention to what we are doing. So don't get too caught in the details of like the specific things that we are doing. Try to have more of a bird's eye, a big picture thing, a big picture vision of what we are doing, because all of the details of all the functions are going to be there. Okay? All right. Now, we are going to talk about how to run the code. This is very important because, again, for the workflow, it can save you a lot of time if you know the shortcuts and how exactly to do this. So all of the things that are followed by this number symbol, those are comments. Those are things that are not going to run, are not going to be executed when you run a code. All of the things that appear, they usually appear in green. So that's how you know also that they are comments, they are just text, and they are not going to be executed. All of the things that appear in blue and then don't have the number at the left of them are actually pieces of code. So these are the ones that you are going to run, and you are going to see an output in the console. So how do you run this? For PC users, you place yourself in whatever place in whatever position, but it has to be within the line that you want to run, and you press Control Enter. And then you see, you go to the next line, to the next non-empty line. And you see that it executed the code, and because it executed the code, you can see the 4 in your console. You should see a number 4 because it executed your code. If you want, for Mac users, the commands are Command Enter instead of Control Enter. So, but it's very similar. If you want to stay in the same line, so not pass to the next line, when you execute the code, you have to hit or press Alt-Enter. And then you will see again in your console that the code actually ran. This is very important. I see sometimes many people, when just start, they think that they have to highlight the entire line of code in order to run it. You don't need to do that. And if you realize that only placing yourself in whatever position within the line will do the trick, it will save you a ton of time. But if you want to run just a piece of the code, just a piece of one line, then is when you want to go and highlight only that specific piece that you want to run. So for example here, if I only select the 2, then it's only going to run the number 2. It's only going to run that specific piece. These bits are very important because, again, like for the workflow, it's gonna make your workflow faster if you don't have to be highlighting everything or selecting everything, okay? An important message to understand when ARI is working is that whenever ARI is processing a piece of code that you have given it, there's gonna be a stop sign working right here. It's gonna appear here at the right corner of the console, a stop sign. So that's how you know ARI is working. And so if you have run a piece of code and it's not doing anything, try not to freak out a lot, like try to have a little bit of patience because what it means is that it's working. And sometimes like the models that we are going to see throughout the days are very computationally expensive, so it's gonna take time. But it's not that it has crashed or that something went wrong. It's just that it's working. Okay. Another very useful piece of advice for writing code and for working with code is the commenting. So if you want to be very efficient with the coding, with commenting big chunks of code, you can just press Control, Shift, and C in your PC, or Command, Shift, and C at the same time in your Mac, and that's going to comment or uncomment a whole section. So you can try that. And that's a very handy thing when you decide, oh, this piece is not working for me, or I want to omit this piece, then it's very handy. It's very easy, yeah? Okay, so far we can place ourselves into R. We know more or less the big structure of R, what we are seeing. Now we can start developing a session, performing a session. So the first thing that you want to do when you start a session is to clear the space. So if you run this command, remove list, if you press on it, what is going to happen is that any objects that you had previously stored in your global environment, they are going to disappear. And this is a very good practice because in that way, you are going to have like a clean slate in which you can start from zero, and your environment is not, R is not gonna get confused with the different objects if you have objects that are named in the same way. So it's a very good practice to start every session cleaning everything that you have in your environment. All right, so now that we have seen like the very basic starting of a session, we can start seeing basic elements of R. Everything that you do in R, and this is one of those principles that can really guide you when you are looking for answers, is that everything in R is going to be functions and operators, everything. So what is a function? A function is like a command like this that is followed by a parenthesis. So whenever you see parentheses, know that this is a function. This is a function. So what a function is a command that takes inputs. In this case, is 2 and 2, so are going to be the things that go inside the parentheses. It performs actions. In this case, this function sum is going to perform the action of summing these two elements, and it's going to return an output. So if we run it, we see that the output that we get is 4, and we see that in the console. So the things that go inside the parentheses, we call them arguments. I'm going to tell you that it's very important that you understand this vocabulary of arguments, functions, these different things, because when you are looking for answers to specific problems, specific questions, this is the vocabulary that the people who are providing the answers are going to use. So if you get accustomed to knowing what an argument is, what a function is, then your life is gonna be easier. Okay. You can also nest functions. So you can see here maybe I can show this in here. Start showing it from here. You can see here that one function, so find the maximum value between 5 and 0, and another function, find the maximum value of between 3 and 2, is nested, is within a bigger function that is, and then sum the result of that. And the important thing to know about this is that they will be evaluated just as in math from the inside out. So this is very important. Sometimes you find a new function, you learn about some new function that you want to understand. If that happens and you don't know how to use it, you can always put a sign of a question mark and then the name of the function that you want to know about. And if you run the command, then if you run the code, then you will see in the help pane R documentation. So this R documentation is going to give you a description of what the function is doing and how to use it. It's going to explain what the arguments are. So then you can see, oh, arguments. These are the things that go inside the function, and it's going to give you an explanation of what exactly goes inside. And usually, too, it comes with several examples. So here you have some examples. So whenever you are confused about how to use a function, you don't know very well, like you forgot maybe about the arguments or what is going to return to you, it's a very good practice to seek for help. If you forgot what the required arguments are for a function, you can just press the code arguments and the name of the function, and it's going to tell you what are the required arguments for that function. In the case of calculating a mean, it just needs a number. That's what it's telling you, x. That is just a number of or an object. And if you need more information, then you can go to the help, package help, and then you can see what x means. So here we see usage x, and a little bit below in the arguments, it tells you, oh, it's an art object. Sometimes this will be more informative, like when you have more specific functions about social network analysis and the objects are not so general as an object. Sometimes it will be more specific. And so it will be more useful when you find these very specific functions that require a very specific type of object. Okay. Functions are nested within packages. And so the packages are like sets of functions that are very specific. So usually packages have a different task, a certain task that they try to accomplish. So for example, we have packages for social network analysis. We have certain functions and packages that are installed in R by default, but some of them are not. And this is why before starting these workshops, we ask you to install a whole set of packages so that we can have them in the memory of R and we can use them when we need to retrieve functions. So if you have not run the preparation code, the file that was in the Dropbox in the 00 folder, in the pre-workshop folder, you need to do that before continuing with this workshop, because many of the functions that we are going to run depend on you having installed those packages. Once you install a package, and you probably saw this whenever you have installed packages, or yesterday or the days before when you run the script that we sent for installing packages, many red messages are going to appear. This is completely normal. This is not an error or nothing bad happened. It's very normal, and what it's telling you is that it's in the process of installing a package. The only time when you need to know, when you need to stop and is really worrisome, is when you, at the very end of an R processing code, has told you there's an error or a warning. And it's also going to come in red message, but it's going to tell you this is a warning or this is an error. And then you can say, okay, something happened here. But if you're just receiving messages after installing a package, that's totally normal. Even if you style packages in R, those are not necessarily going to be in the working memory of R. So in your specific session, so that you can use the functions. So to make your package available for you to use within a specific session, you need to load, to bring the package into the working environment. And how we will do that is with library, with this function library. So if we run this command, if we run this piece of code, we are going to see that the package is loaded. Let me show you, because this is very important, that when you load a package, you will often see many messages. And one of the messages that is very important to know about is about conflicts. So this is the message that we got when we loaded the tidyverse package. The tidyverse package is really a set of packages. It has many packages for many different things. So it has, for example, ggplot, that is for plotting, tidyr, that is for data manipulation. This will become clear in the future. The point is that some of the packages that tidyverse installed, that tidyverse is loading, are in conflict with packages that you had installed in R by default, that is the stats package. And so when you get this conflict message, what is going to happen is that the new package is going to mask the previous package. And what do I mean by that? This package dplyr, that was installed and loaded through the tidyverse, has functions that have the same name, filter, for example, or lag that have the same name of a package that you had stored before. And so what happens is now whenever you want to call those functions, R is going to adopt the ones of the newest package that was loaded, that in this case is dplyr. And so if that happens and you try to run the function filter without acknowledging that this conflict happened, you're going to try to do that and the function is going to behave in a different way because it's not filtered from stats anymore. It's filtered from dplyr. And so you have to kind of be aware of this because sometimes, especially when you get an error that says couldn't find function, is sometimes because of that, or when the function is behaving in a different way to the one that you expected. And so if you want to still use the function filter, but from the stats package, what you can do is this piece of code, stats, double colon, and the name of the function that specifically you want to use. So the double colon here is just telling you that this function is going to come from this specific package. Okay, so right now we know that R is a combination of functions and operators. Now, we know about the functions, how the functions operate. We know that they come with parentheses. We know that they have arguments, but what about the operators? The operators simply allow us to do different tasks. For example, we have arithmetic operators, plus, minus, by, that allow us to do just simple arithmetic operations. We also have relational operations that let us know if a number is greater than, less than, equal to, equal or to or less than, etc. Like different relational statements. And these are going to come very handy, for example, very handy when you have to select observations according to a certain condition. So for example, let's say that you want to select from your data set only observations only people whose age is equal to 65. Then you have to know, oh, how do I tell R what equal is? And it's not just a one equal sign. For equality, you have to use two equal signs. So it is important to know whenever you are trying to find a condition and write a condition in your code, it is important to go back to the relational operators if you're having trouble trying to figure out how to put that statement, how to tell R to find the people whose age is equal to 65. We also have logical operators. The exclamation one is not, then we have and then we have or. This will also come handy when you are also working with if statements, if you have to give a certain condition of when to exclude people. For example, you can say is not equal, which uses the logical operator no. So these are the things that you can go back to this script and try to find if you find yourself, oh, I need to write a condition and I'm not sure of how. A very important operator is the assignment operator. The assignment operator, there are many other operators, but I'm trying to give you just the things that I think really matter for social network analysis. So we are not going to cover more operators, but just know that there are many more. The assignment operator is very important because it's the operator that is going to help you create objects. So whenever you have this operator, you can understand it as replacing the word gets. So for example, in this piece of code, I'm telling R, A gets 1. And so you are assigning the element 1, you are assigning 1 to the object A. Whenever you create, so if you run this command, if you run this piece of code, A gets 1, you are going to see that the object A is going to appear in your global environment. So if you do that, you are going to see that okay. Now A is here in your global environment. So that's how you can know that you actually created an object. Now you can use a very handy shortcut for this. because you will be using you will be creating many objects, is a task that you're going to be using a lot. So for getting the assignment operator, one option you can do is simply click Alt and minus, see? And then you get that one. And in Mac is Option plus the minus sign. And that's how you get the assignment operator with a very easy trick. All right. Both the assignment, like the arrow, and the equal sign are assignment operators, but because sometimes it's confusing and for more technical details, it's always better to use the arrow and instead of the equal sign. But know that when you are trying to find answers in the Google, in other places, sometimes you will see equal, and it means that the person is assigning an object the person is assigning some stuff to an object. So just know that, recognize that this is also an assignment operator. Now, there are very important rules for how you have to name objects. You can't use spaces in object names. All the object names have to be just one string, no spaces. You shouldn't use names that could get confused with functions, with other elements of R. So don't use false, true, if that is for infinity, for if, any of those things. Even C, sometimes I see people using the letters of the alphabet. So when they use the letters of the alphabet, they use A, B, C, and C is also a name of a very common function. So then you can get into mistakes and are not behaving the way you want because you are giving names that are confusing. So one very good rule that you can use that usually allows you to create objects that R doesn't have is if you have objects that are my underscore and the data, or my underscore variables, or my underscore, and in that way you sidestep these obstacles. Another thing to take into account is that R is case sensitive. So if you are going to use capital letters in the names that you assign to the objects you create, R only will recognize your object in subsequent calls that you make if you use the exact same name with the exact same capitalization. So if you try to use lowercase to call for your object later, that's not going to work. So if you have into account these three rules, you are set to create objects. Another thing that is important, but still like we can mention is a little obvious, but okay, is that you can create objects that are the output of a function. So you can assign an object to the mean of 2 and 4, for example. And this is going to be helpful because later on you can assign objects to models, you can assign objects to outputs, to any result that you can get. We will see many examples of doing this throughout the code. Now, if you want to look at the object you created, you can simply either select just the object in the line of your code and press Ctrl Enter, or write again the name of your object and press Ctrl Enter. And when you do that, you are going to see the result of your object in your console. So if we do that, then we see here the result, the output in our console. Okay? Sometimes people don't like to store many objects in the global environment because you can see that if you are working a lot and you're creating many objects, this global environment has only so much space. So if you want to create objects but be removing them just because of keeping things clean, you can always use the remove command, the remove function. That's RM. And as you saw, like I only removed A and is no longer in my global environment. You can also overwrite the objects that you create. So let's say, again, that you run this piece of code. Now A is equal to 3. And we can reassign A so that now A gets 1. And you see in the global environment the change. So you can always overwrite the objects that you create. You can remove them from the environment. So these are pretty handy functions that you can have for creating and removing objects. All right, so that's really the very, very basic elements of R. Now we're going to get into a little bit more complicated stuff, that is how R handles the data. And R handles the data in data types and data structures. This is very important. This seems dry. I know that it seems dry and it's very far from what you're very interested in, but it's very important because sometimes, many times, all the time, the functions require data structures or certain data types. So you need to know what data types are, what data structures are, because if a function is requiring you to use a certain data type of a certain data structure and you get an error, by reading the error, you will know that it's about a data type, a data structure, if you can recognize the different data types and data structures. So this is why it is very important to be able to distinguish them and to be able to work with them. And this is something like the data types and data structures that R has are a little bit different from the ones that you can get in other software. So this is why this is important. It is also very important to know the data types and the data structures, because odds are like you will certainly need to look at the elements of your objects. When you have like a network, when you have different objects or just your data set, you will need to locate different elements within that data set, within that network. And networks and data sets are very specific types of data structures. So you need to know how you can inspect them, how you can access an element, how you can look at your data structure. Okay. So now let's get into the very specific data types. I am being a little comprehensive here because I want you to know this will appear all the time. So I really want you to understand when you see these symbols, what they mean. So integer, the first data type is an integer. That means that they are numbers, but they don't have decimals. So 1, 2, 3, 4. And the symbol that you will see is this int. So whenever you see the int and this is another object, like in many contexts, this means that it's an integer. A double you will also see all the time, and so many people are confused by this. It's basically an integer, but they have this other name, double precision floating point number. I guess that for some very technical stuff is important, but for our purposes, integers and doubles are used in the same way. So, but it's important for you to know that this is the case, so that later on you are not gonna get confused, and you will see this a lot. So I really want you to know this. Numeric, the numeric type is they are numbers again, but now we can use decimals and negative numbers. Integers, doubles, and numeric types are often treated interchangeably in the different functions that we run. We also have character types that are text, or you can also use numbers as text. And the way to do that is to insert them into quotation marks. So whenever you use the quotation marks, it means that you want to treat something as a piece of text, not necessarily a number, even if it's a number. And you have factors that are categorical variables with labels. Now, you know that if you can think of experiments that like factors with labels or variables where you have different categories and they are different levels, this is what a factor is. Now, they are because they are categorical variables, they are usually R treats them in a way that is similar to the character or interprets characters as being categorical variables with labels. This is a part that is very finicky. The factors in R is one of those finicky parts. But I'm going to show you what kind of things are going to happen when R treats character variables as factors and what can you do about that. So you will see this will make sense. This part of the factors will make sense just in a little bit. And the logical data types that are just true or false statements. So these are basically the data types. Okay. So here, if you run the code A gets 1, then A, and then B gets hello. So let's do that in our code. If we run this, we can figure out what is the data type of each of these objects. So if we ask R, what is the class of A? It's going to tell us, oh, it's a numeric data type. And if we ask, what is the class of B? Is a character type. And we can also tell R to convert the type. Yes, sorry. Yeah, yeah, the majority of time. You can do that if it's character and factor. But for example, if it's character, you cannot translate it into a numeric one. So it's using between the compatible ones. Yes. Can you try to go back just a little bit in the code and try to run this part from the B? From there again? Working? Yeah. Yeah. No, this is normal, yeah. Okay, we can also do type conversions. So type conversions is just what you were mentioning. We have an object in a certain data type and we want to convert it into another type. Again, this is a very handy task when you are trying to run a function with R and it's not working because R needs another type of data. So then you can convert A, that was a number. As I said, like you can convert numbers into characters, but not the other way around. So for example, we have A that is going to be numbers. So as you were saying, because they are in quotation marks, these are characters. If we ask about the class, these are characters, and you can try to convert them to numeric, and then they transform into numeric values. Okay, so that is everything about the data types. Now let's get into the data structures. The data structures are also very important in R. We have basically 4 types of data structures that we care about. There are more, but again, for the purposes of these workshops, these are the ones that we really care about. First of all, we have vectors. The important thing to distinguish between the data structures is the dimensions that they can have and the data type that they can store. So vectors is just one string. It's just a sequence of elements. And all of these elements have to be of the same type. Vectors are very common in R, and we will see how. So if you run this piece of code, my vector, see, that's the good name that I was telling you about. My vector, and you give him a sequence, and I'm going to explain like this C function is a function that combines elements. So every element is going to have a comma, and the C function is going to combine. So if you run that piece of code and then run my vector again to inspect what we have the sequence 1, 2, 3, 4, 5. We can also do that, and this is also a very handy piece of code. We can also do that using the column. So the column means from the element that is at the left to the element that is at the right. So if you run this, and then you see what my vector 2 has, is also 1, 2, 3, 4, 5. That is exactly the same thing that we got from the first vector. Yeah, so this is another very handy thing. We can also have a vector that combines elements, But when we combine elements, because the vector can only store one type of data, the elements are going to be coerced into one type. So even though here you see that we are trying to create a vector, and the vector has this character element, very clearly A is a character, very clearly B is a character, very clearly C is a character. But when it finds one should be a number, and we are not putting it into quotation marks. But because vectors can only store one type of data, then we see that it appears with the quotation marks because R transformed it, coerced it into being a character type. These things seem dry, but are very important when you are trying to do more complex stuff. Okay. Now we can see the data frame. Data frame is another type of data structure. Now we are going to have 2 dimensions, and now we can store multiple data types. So the data frame is really going to be like the typical data set that you are accustomed to use, or that you are accustomed to see. Is the data set, the data table that we see in Excel, is that kind of thing. So here I'm just gonna create a data frame. If you run this piece of code, my data frame, and you run also this piece of code to inspect what we have in my data frame, we will see that we have a structure that is 2-dimensional. So we have rows, we have the rows here, and we also have columns. So then you have 2-dimensional. You can also use in class inspect what type of data structure we have. So if you run class my data frame, then you will see that is a data frame. Also a very handy thing when you have to convert data structures because your function needs a very specific data structure. Now, in a data frame, usually the columns are treated as variables, and the rows are your observations, so your typical data set. Now, the good thing about the data frames is that it can store multiple data types. So here, the multiple data types is that different columns can have different data types, but each column is going to be a vector. So within columns, the objects, the elements of each column are and have to be of the same type. So this is important because you cannot have, for example, grade here 7, and let's say that here you wrote in text 7, then both things are going to be converted into a character, so you cannot have like different data types within a column. The column is going to have all of its elements of the same data type. Okay. Now the third type that we are going to see is I don't know how they pronounce this one, is a new object that our people created, table, I don't know. But it's basic, but I'm telling you about this one because you are going to find it time and time again, like is a new thing and it's going to appear a lot. And this table, like this table, is going to be basically as a data frame. The difference between this table and the data frame is just how it is organized. There are all the other technical stuff, but it's not really important. The basic feature is that you can see here that a table gives you more information. So for each column, it is telling you the type of the data that column is storing. So here we have the names, and it's already telling you, oh, this is a character. Another last name, and this is a character. Yes. Can you say that again? Yeah, yeah, yeah. You could do that. It's gonna work the same. So it's more because also another difference is more a practical thing. Another difference is when you have a big data frame and you call, like you do this, like you call the entire data frame, the whole data frame is going to appear in your console. And so it's going to clutter a lot. But they created this table because in this one only shows you up to the 10 first observations. So it's way more practical because it's not gonna clutter your computer. So it was not created for modeling or for like fancy stuff. It was more for practical stuff. Okay, here you can see, for example, here's that kind of thing that I tell you. You are going to find the double in many places, and it's not intuitive what DVL means, but it's just a number. And then I put a variable that is called vaccine, and it's telling me this is a logical type because it has false, true, false, true. Okay? So this one is going to behave exactly, very similar, exactly as the data frame. If you, this is a little weird, but it's okay, it doesn't do anything, is that if you try to find the class of a table, it's not gonna tell you it's a table, it's gonna give you these three things. But it's essentially the same. Matrices. Matrices is the fourth type that we are going to see. These are also two-dimensional structures, but they are going to have only one data type. And this is very different from the data frames. The data frames can have multiple data types. The matrices have only one data type. And so if you run this, you can see that it has a little bit of a different structure. You can tell very clearly when this is a matrix. And matrices are sometimes important for some network stuff because, as you saw Jim explain, many things, especially in the past, were processed in matrices. So sometimes you are going to find this. So this is why I'm including them in this tutorial. And now we have lists. Lists are very important elements of R because networks are stored as lists. It will make sense tomorrow, and I will show you how networks are stored in lists, and I will show you how it will look. But for today, let's just understand what a list is. A list is an object that can store multiple data structures. So it stores other data structures. We created a vector, a data frame, a table, and a matrix, and we can store all of them in a list. And now you can see, if we inspect the list, we see that the first element is a vector, the second element is a data frame, then you have the table, and then you have the matrix. So as you can see, the list is a very, very particular type of data structure because it can store other data structures. Now, just as we did with the data type conversions, we can also convert different data structures. Again, the importance of this is when you get an error because the specific function that you wanted to run required some specific data structure. So this is the only reason why we are not the only, but one of the main reasons why we are learning this. So again, we can use class to figure out what the class of your object is. And we can convert, for example, the matrix into a data frame. And if we do that, we see that because data frames are usually understood as data sets and the columns are variables, it already converted the columns into variables. And so V1, V2, and V3 stands for variable 1, variable 2, variable 3, or vector 1, vector 2, vector 3, because columns are vectors. So let's turn back into the matrix. If you try to turn it back into a matrix, now you see that instead of having here the names of the columns in numbers, it retained the names of the columns as the columns of the matrix. So, but essentially is the same object. Now we're gonna get into indexing. Indexing is also a very important concept because it allows you to inspect and have access to the objects that you have and their elements. And the important thing about this is that different data structures have different ways of being indexed. So you have to learn how to index a certain data structure because not all of them work in the same way. And everything is tied, like the number of dimensions they have also affect the indexing that they have. And we're just gonna see right now, how this is gonna work. Now, let's create, if you run this piece of code, my new vector, and we assign it the elements 1, 5, and 8. Because it's only one dimension, we are just going to get to have one set of brackets. And if we write one set of brackets right next to my new vector, my new vec, and run this piece of code, we are going to see all of the elements that we have, 1, 5, and 8. Now, this empty bracket is going to give us all of the elements. If you want to access one specific element, you have to insert within the bracket the numbered position of the object you want to access. So let's say I want to see what I have as the first element of my vector. So then you will write 1 inside of the brackets, and it's going to tell you what is your first element. What is the first element of that data structure? It returns 1 because 1 was the first element of the vector. Now, you can also ask R to tell you, to give you access to multiple elements of a same data structure at the same time. So if you do that, how we do this is, again, we use our now familiar, very familiar combine function. So we combine the first element with the third element, and we put them inside the brackets, and we ask R, okay, R, tell me which are the first element and the third element of my data structure vector. And then it's going to return your first element, which was 1, and your eighth element, and your third element that was 8. So simple. You can, relatively simple. So far, so good. So now you can call, as I said, like many multiple elements within the same structure. So we can insert all of the elements, call all of the elements in the same way with using the combine function. And as we learned before, we can also use the colon. That means from to. And we can see how this is a very good shortcut. Instead of having to write C, 1, 2, 3, we just write 1 from 1 to 3, and we are going to get all of the elements from 1 to 3 of that data structure. And it's the same, we get the same result, 1, 5, and 8. All right, so now we have learned how to index a vector. Now we are going to look at how to index a data frame. Because data frames have 2 dimensions and multiple data types, but more importantly, 2 dimensions, they are going to have a different way of being called, a different way of being indexed. So remember my data frame. We have my data frame with the names, the last names, and the grade. Now, because it has 2 dimensions, now we are going to use the brackets, but the brackets are going to have a comma inside the brackets. That's very important because the rows are going to go at the left of the comma, and the columns are going to go at the right of the comma. If you leave this empty and just run my data frame and the brackets with the comma alone, you're going to get the whole data frame. That means call all of the elements that are like either rows and columns, call all of the elements when you leave it empty. And so you can see we get the same data frame that we had originally. It's exactly the same data frame. Now, what if you just want to look at one specific row? So here we can do that. We tell, okay, tell me what is in the second row of my data frame. Again, we are gonna leave this columns place, the place of the columns empty, and it's gonna give us all of the columns. So if we run this piece of code, we get all the data frame, like only the second row of the data frame, but all of the columns because we left the columns empty, and we get all of the second row. See? And now, using the same principle, we can tell R, okay, R, tell me what it is in the second row and in the second column. So because rows go at the left of the comma, we ask for the second row, and columns go at the right of the comma, so we ask for the second column. And then we see what is in the second row, second column, Johnson. Now, very interesting. When it told me, oh, Johnson is telling me levels, Johnson, Smith, Williams. What does that mean? That means that's where the factors come into place. They were characters, like everybody could agree that these were names. Is Johnson is like a last name, it seems just like a string of text, but sometimes R automatically interprets the characters as factors, and he thinks that they are levels of a variable. And the way that you know this happens is when you call an object of that variable, and it tells you, oh, it has the levels, and then you know it recognizes it as a factor. This is a way of knowing, or if you haven't run like the class function, it will also tell you. But this is a pretty handy way to know is recognizing this as a factor. And that could be a problem depending on the function that you use, because sometimes functions use factors and sometimes functions use characters and don't like factors, so you have to know. Okay, we can also, just as we did with the vectors example, we can also select multiple observations and multiple elements within data frames. So here again, we will always use the comma to separate the two dimensions, and we can tell R, tell me what it is from the second to the third row and first and third column. So that's all we are doing. We are using the same principles that we were using before, the combine function, the from to column, to just call multiple elements of an object. It's the same principle. Just that because it's a two-dimensional stuff, you have to use the comma. And see, then is returning. We ask from the second to third, and it's giving us second and third row. And we ask for the first and third element, and it's giving us the first and third element, like the first and third column. Okay? So we can also call columns by the name of the variable. So if you prefer that, sometimes that's easier if you know the name of the variable. Instead, if you don't know the position, it's easier. Sometimes you can also call them using this symbol. That's also pretty handy. And you can call elements in the same way, because columns are vectors. You can call the element within a vector using this same logic, like using this money element and this money symbol, and then the dollar symbol, and then the name of the variable, and asking it for the third element within the vector, that is the column name. Okay? The same principle is going to apply with matrices. Matrices are also two-dimensional, and so we use a comma to separate rows from columns. And it's exactly the same principle. I'm not going to go over it too much. Lists. To get a list, to access list, this is going to be a little bit different from the other ones. But again, this is very, very important, because to access the elements of your network, you are going to need these functions, these specific functions that I'm going to tell you, like these specific indexing things. So to call we talked about lists and they having multiple components, they having multiple structures. The data structures within a list are called components. And so you can call a component within a list having double brackets. So remember, my list was the list of the vector, the data frame, the table, the matrix that we had created. So if we ask for the first component of my list, it's going to return the first element, the first object that we put in there, that was our vector. Yeah? So you can see, if we ask for the first element, for the first data structure, it gives us the vector. You can also call elements within a list in the same way that we call elements within a data frame, with the dollar sign. So this is the same. We call the first element using the double brackets. We can call it the same way using the dollar sign and the name of the data structure. We can also, in the same way that we did with other data structures, we can call this data structure using quotation marks within the double brackets. Remember, lists, work with double brackets. And then we can also inspect elements within a data structure within a list. And to do that, we're going to use the double brackets first to ask for for a component, and then a single bracket to ask for the second element, but that's because the first element, the first component is a vector. So the way to ask for elements within a component is depending on the data structure that you have. So because the first component that we had on my list was a vector, we only use the bracket. But if it was a data frame, we would use or a table or a matrix because they are two-dimensional. Now we have to use, after the double brackets, asking for the component, the bracket with comma for the elements. So you see how different moving parts work together and how everything like makes sense in its own way, and how different data structures have different ways of being indexed. Okay, so with that, you have like the basic elements of R, the basic structures, the basic things that are going to help you a lot. Now we're gonna get into more interesting stuff. We're gonna get into importing the data, exploring the data, and manipulating data. Now, for importing the data, the first thing we need to do, importing the data, is just getting our data into R. The first thing we need to do is to get our working directory set. So for getting our working directory, we run this command, the get working directory, and that is going to tell you what folder R is currently using. So how is this going to work? You want to tell R where you're going to be working in terms of a folder. You want to grab all the files from a certain folder. Let's say that is the folder in your PC, in your Mac, where you have stored all of the files for a given project. So then what you want to do is tell R to start grabbing everything from that same folder so that you don't have to tell R the whole file path every time that you want to call for an object. So the first thing you want to do is get your working directory. If you run this command, this line of code, R is going to tell you sometimes, usually something very general, like user and your name. And what you want to tell him is set your working directory. So I didn't run that in my computer, but what you can do and will do if you want to set your working directory is just uncomment this and put the file path of where you want to put the working directory. And so to do that, it has different options depending on the Mac and the PC, but I'm giving you here a quick tutorial of how to do that. We're not gonna do that today right now. Like that is something that you can do like at home. It will be better because sometimes it takes time and it's better to read the tutorial, this part, and do it on your own. But what we are going to do now is we don't need to have the working directory and have to move files because we can read. We are going to grab a file directly from our Dropbox. So for importing data, what you need to have is a function that is going to read your data. And there are different functions for different types of files. So we have CSV files, data files, if you work with the data, SPSS files, SAS. So the task here will be to recognize what type of data, what is the file type that you have, so that you can run one of these functions with your own data. Here, as an example, I'm going to use a CSV file. So I'm going to use the function read.csv. And if you run this line of code, it should work. You should grab the data set, the exact data set that is in the Dropbox folder. If you want to play with this and play with this part of setting your working directory, you can grab the same file that is in the Dropbox folder, place it in your computer, and do this part of the tutorial so that you can set your working directory. Now, this is the data set that we are going to explore, to manipulate, and to view today. I'm not gonna get through all of this. functions today. Part of this will go tomorrow, like the manipulation of data and the processing of the data. But I just want you to know that today, tomorrow, and on Wednesday, we are going to work on the same data set. So it's important for you to know that there is going to be some continuity. And so we're going to get familiar with this data set today, tomorrow, and on Wednesday. Okay. So we are going to get into, now that we read the file, you should definitely see that the file should appear in your global environment. So let me do that here in my own code so that you see. Okay. If I read this one, see, there's the stop sign. They're telling me R is thinking. Once it has done that, the data set should appear here in the global environment. See, and that you see that it has correctly loaded. Okay. And so now we can start working with this data set. This data set was created, is a synthetic data set. That means a data set that is fake, that we created for the purposes of these specific workshops. So the data set is a representation of an adolescent friendship network. Each respondent nominates up to 5 male friends and 5 female friends. And the data set also contains some other information about the grade, the sex, the race, sexual and smoking behavior of each respondent. For the purposes of today and part of tomorrow, we are going to ignore the NA's impossible values. So you are going to see some weird things happening in this data set as it is right now. We are going to clean it later, but just know that this is completely normal. Okay? So the first thing that we can do is identify the class of your data set. And we know as many data types, many data structures that are data frames, that many data sets that is a data frame. Next, to explore the data, we can use the glimpse function. And what that is going to tell you is how many observations you have, how many variables you have, and for each variable is going to tell you the name of the variable, what type is it. So then you can see integer, double, numeric, all of that. And it's going to give you the first observations of each variable. So this is gonna come very handy when you try to understand your data, because here you can see in a from a bird's eye position what you have in your data set. Now you use this in conjunction with your codebook to figure out what each variable contains, how it was coded, and to figure out what you have in your data set. So here in the Dropbox lab, I have the codebook for this data set. The important thing we know is that all of the variables that are MF, NID, 1 to 3 to 5 are the male friends. And all of the variables that are FF, NID, 1 to 5 are the female friends. And our responders are the ego NID. So that's the code, the ID for each respondent. We also here we see that we have race, grade, and sex, but those names are very intuitive. The important thing is to figure out that these MF, NID are the friendships. Okay, so taking this into account, we can keep exploring the data set that we have. We can look at the names of our columns. So if we run the function names with the data set, we see what are the names of the columns, and that's gonna be pretty handy. We can also look at the first and the last rows. So if we look at the first rows, we see head, and that's gonna give us like the first 6 rows. We also can set this to give us only like the 2 first rows if we add an n equal and the number of rows that you want to see. And we also can use the tail function, and that is gonna let us see the last 6 rows. The last 6 rows, you can also tailor it so that it tells you the last 2 rows or 10 rows or whatever is useful for you. And sometimes like after the 10th observation, this should happen. So then you set it to be 11, and then you can see things, you can explore the data in different ways. So these functions are very handy for exploring the data, for getting a sense of what you have. You can also, another very useful function for data exploration is the summary function. The summary function is gonna give you for each variable that you have, what's the minimum, the maximum. Very importantly, it's going to tell you the NAs, the number of NAs that you have per each variable. And this is where you can see, okay, for the variables that I'm interested in, are the values sensical? Is the fact that this community starts at 1 and ends at 85, is that sensical? The number of NAs that I'm having, is that all right? Should I be worried about something? You know, this summary function is very powerful. We can also make more specific crosstabs if we want to have just a crosstab of 2 variables. So with this line of code, very important. So we are saying here, make a table of sex, the variable sex, grade, with this data set. That's all we are doing. And we are adding this very useful trick. Use NA, if any, and that's going to tell us if there's any NA, if there's any missing value in the crosstab that we are making. So these are very handy things to see. We can also visualize the data that we have. For example, we can use bar plot to get to see what the distribution of the variables that we have. We have many others, many other types of visualization. I'm only using the ones that make sense according to the data set that I have. These variable tot nums are the total nominations that respondents made. So we see that many respondents had 0 nominations. They nominated no one. They didn't say they have any friends. And there are also many people that nominated 10 friends. So we see here, very handy, the distribution of how many people people said they were friends with. Okay, so until here, we have done everything that is about the basics of R, how we can understand R, the basic elements, the moving parts, and some data exploration. Thinking about the time, it's all right, it's gonna feed in tomorrow. We're not gonna have time today to go to all of the manipulating data functions. We are going to do some, but if we don't finish today, it's all right. I take on tomorrow and we are using the same data set. So let's look at a couple of manipulating data functions and we will call it a day, okay? So manipulating data, it works with very specific functions, very specific verbs that allow us to do very specific tasks. So for example, we have the verb select. The verb select is allowing you to extract from a data set the columns that we want. Now, for all of the functions that I'm going to talk about in the following section, I'm going to give you the name of the function, select. I'm going to tell you what it is doing, and I'm going to give you how to use it, what the arguments are. So in the case of select, we see that select, we need to tell select what data set we want to select the columns from, and then we have to tell R the names of the columns that we want to select. So for example, in our data set, let's say that we want to select only the variables ego and ID, sex, and grade. If we run this command and only see the head of what we get, we see that now we only have 3 columns, Diego NID, Ego NID, sex, and grade. So as you can see, like these functions are very handy for manipulating the data set that you have. We'll talk more about these functions tomorrow, and they will all come together in the data cleaning process. And we will actually do the data cleaning of this particular data set that I'm working on. But I want to show you how these functions usually work. You give them the data, you tell them what to do with it, and then you specify like the specific columns or what to modify, what elements it needs for these modifications. So that's how it's going to work. Okay? Now note also that across all of the tasks that I'm doing, I'm creating an object that is called my select or my field or my different things so that you can inspect these things very quickly, very easily, and it's gonna look in your, it's gonna show in your computer without overwriting the original data set. So that's my intention here. I'm not overwriting the original data set. And that's a very good practice that you can do for things that you can test, that you want to, you're not sure if it's gonna work or not. First, try to do the test. Give it another name. Do the test, see if it works, and then when you are sure, you can overwrite your original data set in the code. It's not gonna be overwritten in your folder. It's gonna be overwritten just in your script, in your piece of code. Okay? So with that, I leave you today, and tomorrow we are going to go into other very useful functions and bring them together into the data cleaning process. All right? Thank you so much.